Yes. So basically, from this session, we are going to start with digital design. So first, let us see what are all we are going to see in this particular digital design workshop, 30-day digital design workshop. So first, tell me like how many of you are not aware, like fresh to this particular subject. You are very beginner to this particular subject. If you are very beginner to this particular subject, please type B in the chat box. Type B in the chat box if you are beginner in this particular subject, digital design. Yeah. And let's say if you know the subject, like if you are already studied your subject but you have got some gap, like if you have studied in your first year or second year and you have forgotten the subject, then you simply type F. Okay. Yeah. So I think majority of people has already studied this particular digital design subject in their college, and yeah. So you have a brief knowledge, right? So I can say you can have a brief knowledge about this particular digital design, what and all the things which are there in this particular digital design, everything, right? Now, so yeah. So what we are basically going to discuss in this particular workshop is we are going to start with the basic number systems. So we will see what are these number systems, what are these complements. Okay, so what are this ones complement, twos complement, what are all the codes we have, gray code, everything we will try to see in this particular number system concepts, right? And after that we will go to Boolean algebra. So using that Boolean algebra, and we will also see the key maps. So for solving that particular Boolean algebra, we are going to use the concept of key maps. So key maps basically make our job easy to solve the particular Boolean algebra. Then after we will discuss the combinational circuits. So we will see what are these combinational circuits, and we will see some designs related to these combinational circuits. Okay. After completing all the combinational circuits, if possible, we will see the timing analysis in this particular combinational circuit. Like when we are applying the input, at how the propagation delay is acting and how the gate delay is being acting on this particular combinational circuits. Then after we will go to the sequential circuits. First we will discuss what are these latches, what are these flip-flops, everything we will discuss. And after that we will see the applications of this particular sequential circuits, applications of this particular flip-flops. Actually, what are these applications, like counters we have, registers we have, okay, and different things we have, that we will discuss. And after that we will discuss about our FSM design, finite state machines. So if the performance is good up to the last, so we will decide like to whether to continue the FSM and memory design, or else we will see according to the attendance and the performance. Like if someone is attending, or if you cannot attend live, and if you are watching your recordings perfectly, then like we will filter out, like okay, we can connect this particular concepts, advanced level concepts, to this particular person or guy. Okay, so like this we will plan. Okay, so this is the agenda. Okay, so if you cannot attend live also, like if like yesterday, in yesterday's session also we have discussed it, right? So if there is a very urgent thing you need to do, or some other work, some urgent work if you do, okay, no issue, you can watch the recording, but the recording should be watched accordingly. And the attendance sheet will also be shared here in the group. Yeah. So I think everyone also have joined that particular WhatsApp group, right? Everyone joined that particular WhatsApp group. If anyone has haven't joined the WhatsApp group, please ping in the chat. Yeah. So if anyone haven't joined in that particular WhatsApp group, please let me know so that I will post the link here. Okay. Yeah. So let me share my screen. So is the agenda clear? Okay. Not joined up. Can anyone have that particular link? Can anyone copy and paste it in the chat? Okay. Let me share. Yeah. Yes. Thank you, Lokesh. No. This is registration link. I was asking about WhatsApp link. 1 minute. Let me only share. Okay, okay. Yeah, got it. 1 minute. Yes, someone has shared. I will also share one. Yes. Thank you. Shyam, thank you. Yeah. So is the agenda, is it clear for everyone? Like what issue? Can you please post that in the chat? Like what type of issue you're facing while joining? Okay. So is the agenda of this particular workshop, is it clear? Yes. If yes, please type Y. Yes. 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 Yeah. So let me share my screen. I think my screen is also visible, right? Can anyone confirm me? My screen. Yeah. 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 My screen is visible, right? For everyone, is it clear, right? My screen is visible, right? Voice is not clear. My voice is clear, right? Yeah. And my screen is also visible, right? Yeah. Yes. So this is the Calcitex new course, upcoming course, which is starting from 3rd Feb 2025. So we are going to start with RTL design and verification course. And regarding this also, we have discussion. We had a discussion in our yesterday's session. So I'm not going to waste much time in this particular. So if you have any doubts or queries regarding fees or anything, you can dial these two numbers. You can take a screenshot and you can just simply dial these two numbers and you can just talk with them. Okay. Yeah. Now, so basically, we will start with the topic called number systems. So this in this number systems, so we have different types of numbers. We have decimal number system, and we have octal number system, and we have binary number system, and we have hexadecimal number system. Okay. So can anyone tell me what is the decimal number system base of this particular decimal number system? Yes. So base of this decimal number system is 10 and octal 8. Yes. So base is 8 and this binary and this hexadecimal 16. So decimal number system base is 10 and octal number system base is 8 and binary number system base is 2 and hexadecimal number system simply base is 16. So these are the decimal number systems with their these are the number system with their bases. Okay. So this is the definition. So decimal number system is the standard number system used in everyday life, all the integers, and it is also known as a base 10 number system because it is uses only 10 digits, that is 0 to 9. And if you can observe, the base 10 number system has the digits from 0 to 9 only. Okay, so the base 10 number system has the digits from 0 to 9. And what about the octal? So how many digits are present in octal? So for decimal, yes, 0 to 7. That is total 8 number of digits. So in octal, we have only 0 to 7. And in binary, we have only 0 and 1. And in base 16, we have 0 to 15. Okay, we will discuss this hexadecimal. Okay, now. So based on representation, a number in in this system is represented as combination of these digits, where each digit's position represents a power of 10. That is, if we have 354, then it is represented as 3 into 10 power 2 plus 5 into 10 power 1 plus 4 into 10 power 0. Okay, so like this we are going to represent our decimal number system. And coming to this octal number system, the octal number system is a base 8 system. That means it will have the digits from 0 to 7. And it is similar to the decimal number system. The position of each digit represents the power of 8. That is, this is the syntax we are going to follow for converting any octal number to decimal number, that we will see in our upcoming slides. Okay. And coming to this hexadecimal number system, these hexadecimal number systems have digits from 0 to 9, and from 10 we are not going to write 10, we are going to write it as A. A is nothing but 10, B is nothing but 11, and C is nothing but 12, D is nothing but 13, E is 14, and F is 15. So from 0 to 15, 0 to F, we are going to have this particular numbers. Okay, and coming to this use case, it is used in computer programming and digital electronics as a compact representation of binary numbers, since every four binary digits map to one hexadecimal digit. This I will explain in our upcoming slides. Now, coming to this binary number systems, we have only two digits, 0 and 1. You have already know what is mean by this binary numbers. So we use it in our digital electronics and Verilog most oftenly. So this binary number systems we use in computer language, machine language. Okay, zeros and ones, and the base is 2. So remember, for any number system, the number of digits will be less than the base. Okay, so for base, let's say base 4 number system, for base 4 number system, what are all the digits present in this particular base 4 number system? If we have a base 4 number system, then what are all the digits? Yes, only we have 0 to 3. So please do remember, when we are practicing problems also, we have some systems like we have some particular examples like this, where we will see this particular type of example. Okay, so for any number, any base number, the highest digit will be less than a particular base. In the case of base 10, that is decimal number, you have already seen, it is up to 0 to 9, and for hexadecimal it is up to 0 to F. We will use the representation F. Okay, now, so is the introduction to this particular number systems, binary, hexadecimal, decimal, octal, are there clear? Anyone having any doubt regarding this particular? So it's a simple and easy topic, right? So that's why I'm not focusing more upon that. Okay. Yes. Everyone clear, right? Yes. Now, let's see how to convert any binary number into decimal. Okay. Let us see how to convert any binary to decimal conversion. So binary system is base 2. Each digit in a binary number represents a power of 2, starting from 2 power 0 at the rightmost. So write down the binary number first. If you want to convert any binary number into decimal number, so these are the steps. First, write down the particular binary number. Let's say if you have 1010. So this is your binary number to the base 2. So this is how you are going to represent your binary number. And you want to convert it into decimal number base 10. So how you are going to convert? You are going to take the weights of individual and you are going to add. Let's say suppose if you have 1010 to the base 2, and if you want to convert it into base 10. So how you are going to convert? You are going to consider the weights of every digit. 0 into 2 power 0, 1 into 2 power 1, 0 into 2 power 2, and 1 into 2 power 3. And you are going to add all these particular weights. That is 1 into 2 power 3 plus 1 into 2 power 1. Okay. So what is the answer? 8 plus 1, sorry, 8 plus 2, 10. So this is your answer. So this is how you are going to convert your particular binary number. Yes, correct. This is how you are going to convert your binary number into decimal number. Okay. And if you want to generalize anything, let's say if you want to convert any number, if you want to convert any number, let's say octal number to a decimal number, or if you want to convert a hexadecimal number into a decimal number, or we have already seen the binary to decimal. Okay. If you want to convert any number to decimal, just take the weights. Okay. So in the case of octal number, how we are going to take the weight? We are going to take the weight of each and every position, 8 into that particular number into 8 power 0, 8 power 1 into that particular number, 8 square into that particular number. And coming to this hexadecimal, we are going to take the weights of each digit by considering its 16 power n, where n is the number or the position. Okay. And you are going to add this particular weights. Okay. So in general, yes. In general term, if we want to talk, so please remember, if we want to convert any number into decimal number, we are going to take the weights of each position and we are going to add. Okay. Please do remember this. Many will think that it is a easy process, but many will forgot. Many will forget this particular thing. They will be confusing between decimal to other number system conversion and number systems to other number systems to decimal. Am I right or wrong? So many people will get confused in this particular point, right? Yes. So many people will get confusion in this particular point. How to calculate? Yes. How to calculate number systems, other number systems into decimal and decimal to other number systems. Okay. So please do remember, if you want to convert any number system into decimal number system, please consider the weights and or add all the weights. Okay. Is it clear for everyone? Can we move forward? Yes. Let's say if we have 0 triple 1 to the base 2, then how can we convert it into decimal number system? So what is the answer we are getting? 0 triple 1 to the base 2. So what is the end answer we are getting? Yes. So all of you clear about this particular conversions, right? Binary to, yes, decimal number system. Yes, yes, correct. Next, let's see octal to decimal number system. Same, but we are going to take 8 power n, where n is a position. Let's say suppose if we want to convert 175 to the base 8 to base 10. So what is my answer? Please try this and post it in the group chat. 175 to the base 8. We want to convert it into base 10. So what is the final answer? Please calculate and answer. 175 to the base 8. We need to convert it into decimal. 175 to the base 8. We need to convert it into decimal. Yes, yes, yes. So how to convert it? Simple, same. Take the weights of each digit, that is 5 into 8 power 0, 7 into 8 power 1, and 1 into 8 square. 64 plus 56 plus 5, which is nothing but 125 to the base 10. So is it clear? Is it clear for everyone? Shall we move forward?